Hello, so this video is going to be about some traits that a solution to the alignment problem would have to have. This is useful because if you work in AI safety, particularly the technical details of alignment, this is useful to figure out how to narrow focus. You should only really be focusing on these possible solutions to the alignment problem, unless you're trying to go for a partial solution where an AI does good things most of the time, and it isn't that bad, but maybe the AI isn't fully aligned with our values. But if you want an AI to always act in accordance with moral values, it's going to have the traits outlined in this video. Now, if you're unfamiliar with the alignment problem, I recommend you watch these videos, first these three, in this order, 1, 2, 3, then look at this picture from Metaculus, also enter that in the search bar, and then on Metaculus search this up. Watch this video, that video, this video, and then lastly watch this video so you can get started on working on the alignment problem, or at least so you understand or at least so you have a good sense of what this is about. And this video is going to start here.
Anyway, here's your agent. Here's the environment. The agent can take actions to affect the environment, and it can observe the environment to get information about what state the environment's in. There's also a reward system, which uses information from the environment to determine what reward to give the agent. So if the agent is Pac-Man, the environment is the maze, and the reward system is just looking at the score. The agent takes an action, the action affects the environment, the change in the environment creates new observations, and also provides new information to the reward system, which decides what reward to give the agent. And the agent uses the observation and the reward to decide which action to take next. And this kind of goes in a cycle.
Alrighty, so that's already sort of pre-screenshotted onto our diagram here. We're going to be diagramming stuff. For now, you can ignore all the little things I added on. But I should note that the way that perfectly moral agent would act has to match some certain requirements. So everyone and all things, AIs, people, dice, make decisions based off of their options. They can do. Information, what they know about the outcome of choosing each option, of all the options they have. So like if I go downstairs, if I think consequences of me going downstairs, going to a bakery and buying cake are going to involve paying for something, that would fall into this category. That's the information. And then my decision-making process, the decision-making process. Now, to be more general, here's a general description if you'd be curious to read how this works in like dice and stuff, where dice doesn't really consider landing on 6 or anything. But if you're going to want to make so pause here if you want to read this for whatever else you might want to apply to Jim. And the reason why this would be this is necessary if we want our AI to perfectly moral is it should consider every option. It shouldn't, because otherwise it might miss the most moral option. It should utilize information. In this case, the information is where Pac-Man is. Currently, Pac-Man is here. And the state of the maze, and where a ghost is. Currently, there's a ghost there. It should use that information. Then it should have a moral decision-making process based off of its information of its options. Let's say its options are either Pac-Man goes here, or Pac-Man goes here. It should have a moral decision-making process. So, if you want your AI to always act morally, then it's going to need to consider all the options, it's going to need to use information about the real world, and it's going to need to have a moral decision-making process to choose between those options. So let's talk now about what this decision-making process might be. And more specifically, I guess, sort of about philosophy. So, ignore the dogs there for a moment. In fact, I'll just move the dogs and stuff over. That's for in a minute. Let's say you want to buy some bread and some lipstick. Bread costs $5, and sorry, not lipstick, gum. And the gum costs $3. So after you buy the bread, you're willing to pay $5 for the bread. Pay for the the gum. It looks too much like lipstick. You pay for the gum for $3. And you're willing to do this because the value of the gum doesn't change after you bought the bread. So it stays $3. Price that you'd be willing to pay for bread and gum is equal to the price that you'd be willing to pay for bread plus the price you'd be willing to pay for gum. In that case, that's $8. Now let's look at a similar situation. Let's say you want to buy yourself a video game and me a video game. And it's a single-player video game, so the value of you having a video game, the moral value of you having this video game, does not affect the moral value of me having this video game. Let's say you'd be willing to pay 5 days of a dog being happy for you to have this video game. This 1 day of a dog being happy is considered our currency in the land of the moral value of things. So it's worth 5 moral value points for you to have this video game, and a dog being happy for 1 day is worth 1 moral value. And for me, you'd only be willing to pay 3 moral value points for me to have some video game. Now, because the value of me having the video game is independent of the moral value of you having a video game, so not whether you have the video game yet or not, we can the amount of days of dog you'd be willing to pay for both of us to have a video game is equal to the sum of the prices for you to have the video game plus the price for me to have the video game. So moral value is additive in that way. That's already written out here. How is this useful? Well, I'd argue, let's say instead of this graph showing you having a video game and me having a video game, it was you having a new video game today and you having a new video game tomorrow. Now there's a case to be made that the moral value of you having this video game tomorrow, I'm just moving the dots over, this is irrelevant to what I'm saying right now, independent of whether or not you had the video game yesterday. Now maybe you having the video game yesterday changes the state of the future because now you have some progress made in the video game, but we're ignoring that. We're pretending that has no effect. We're not talking about how technically yesterday affects today physically. We're saying morally it doesn't matter that yesterday you had a video game. So you'd be willing to pay so the amount of days of dog being happy you'd be willing to pay for you to have a video game today and tomorrow equal to the price you'd be willing to pay today plus the price you'd be willing to pay tomorrow. How is this applicable to our example here? Well, let's say we were looking at the value of Pac-Man going down this path. I'll just change this back to Pac-Man, so it's like that. What's the value of Pac-Man going like this and eating this ghost? Let's say right now Pac-Man is in that mode where Pac-Man can eat ghosts. Well, because the moral value of different moments in time is independent of each other. I did not mean to do that. Value of Pac-Man going like this equal to the value of Pac-Man being here plus the value of Pac-Man being here plus the value of Pac-Man being here and everywhere in between. So here I wrote that out. This v function is the value of a state of the world. So here the state of Pac-Man being here, the value of that is 2. This state of the world we assign a value of 3, and this state of the world we assign a value of -1. So in total, that is value. All of this is equal to the value of this halfway option. So now all we need to do for our AI to perfectly moral is for us to assign the right moral values to each of these different possible moments in time. Now, in the real world, this is a lot harder, assigning the value of, say, 1 second on Earth where there's twice as many people, or there's twice as many dogs, or I'm happy but everyone else is sad. Assigning that an exact number is pretty hard, but anyways. So that's how, that's part of the decision-making process. Now let's talk a bit about the AI's information. Now, in Pac-Man, we can just draw a path. That's easy. But in the real world, it's much harder to tell how different options will affect the future. Now, for us to be able to tell of different actions, and more specifically, what moments in time that might result in, 1 moment in time where everyone is twice as happy, 1 moment in time where everyone is a little bit sadder. GPT is outputting the words, hello, how can I help you today? Blah, blah, blah. Is that we would have an AI predict based off of the information it has. That might be information that a robot gets from its sensors, or news articles on the internet, or whatever. It tells what the current state of the world is. Options is pretty easy to explicitly write. You can move your motors this way or that way, or for Pac-Man you could go up, left, right, or down. ChatGPT, you could output any string of text that's sufficiently short. So now that we've talked a bit about their information, now move on to the next section where we talk even more about the AI's information. How will it... Well, for an AI to be able to good job at doing good, it's probably going to have to model consciousness. It's going to have to model that the world where everyone is happy is better than the world where everyone is sad. It's going to have to understand consciousness at least a little bit for it to be able to make sense of the fact that a world where everyone is happy is better than a world where everyone is sad. So let's say, in this example, this ghost is conscious. And what I mean by is conscious is just that there's some correlation between states of the world where this ghost exists and states of the world, and a conscious being somewhere out there being happy. And same thing goes with the real world, by the way. There's not really such thing as consciousness being contained within some area in space, or there's no consciousness is in a neuron or anything. There's only correlations between the state of the world and your conscious state. And it just so happens to be the case that your consciousness is highly, highly correlated with what goes on in front of your eyeballs and in front of your ears and what you feel through your skin and whatnot. But anyways, sorry for that tangent there. So let's say we want to analyze, let's say Pac-Man here has the choice to either start out a game of Pac-Man over here or start out a game of Pac-Man over here. Now, for Pac-Man to do that, we're going to want our Pac-Man AI to be able to analyze the value of this moment in time. Now, let's say in this moment of time, there's an 80% chance that this has a pretty strong correlation with the ghost being happy. There's an 80% chance this state of the world, our ghost will be happy, more specifically, +1 happiness. And there's a 20% chance that our ghost is sad. More specifically, it would be twice as sad as it would be happy in this scenario. It's -2 happiness. So, and if it's sad, there's a 40% chance that our ghost goes to the right, and a 60% chance that our ghost goes downwards. And if our ghost is happy, there's a 30% chance that our ghost goes down, 70% chance that our ghost goes to the right. Now, let's say we observed that ghost goes to the right. And we want to know what is the probability that this ghost is happy. Now, here we have a diagram of 100 simulations of this game of Pac-Man being played. And here I highlighted that in these 80, more specifically I'll just write this down. It's 8 across. This is 8 across, and this is 10 across. And this is 2 across, and this is... So, our AI here is going to... So, it's an 80% chance it ends up in one of these scenarios, and a 20% chance it ends up in one of these scenarios. Now, we got 6 out of these 10. Each column, there's a 6... If we zoom in on one column, hold on, base. So if we say we were just looking at, let's say we were looking at just this column, in 6 out of these 10 scenarios, the ghost moves to right, and this lines up this is meant to be moved up a bit. Alright, that's fixed. All better now. So, looking at just this column, in 7 out of the 10 scenarios in this column, our ghost moves to the right, and this is what we want to see. We see it moving to the right in 70% of the scenarios. It's 70% of the scenarios for all of these columns. And here, it's only 40% of the scenarios. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 10 in total. This again lines up. There's a 60% chance that when our ghost is sad in this zone, there's a 60% chance that it'll go down, and only a 40% chance it'll go to the right. So then, what is the probability that our ghost here is happy, given that our ghost went to the right? Well, it is... Here we got... Well, I gotta update this because I did 6 times 8. I meant to do 7 times 8, so that's d6. 6. So then, got 7 here, 8 here, so the number of simulations where the ghost is happy and goes to the right is 7 times 8, and that's 56. And here, 2 out of 10, out of scenarios are 20 out of 100, our ghost is sad, and in 8 out of those, in 4 out of 10 here, 40%, ghost moves to the right when it is sad, so 2 times 4, that's 8. So there will be 8 where our ghost is sad, and 56 where our ghost is happy. And 56 as a percentage of this total is going to be 56 over this amount as a percentage. So that's the percent chance that our ghost is happy, given that it goes to the right. And this is basically how we would update our priors on this. We had were the prior probabilities, the probabilities we got prior to any evidence. And then after we got this evidence that it moves to the right, we now think that there's a 56 out of 56 is 8 times 7. 8 times 7 plus 8 is just times 8. So that's 8 times 8 times 7 over 8 times 8 is. So there's a 7 out of 8 chance that our ghost is happy, given that our ghost went to the right. And we could also update on other things, like maybe instead of just updating on whether the ghost is happy or sad, maybe we update on his probabilities. Now, let's say there's a 50% chance. In fact, instead of this being 30%, let's say it was 40% here. And then let's just add some more arrows. Second. So let's say we weren't sure if a happy ghost just has a 20% chance of going down or a 40% chance of going down if it's happy. Then maybe after this, using basically the same method, we would determine that, and that would give us more information on the correlation between a happy ghost and the ghost doing a certain thing. And maybe we weren't sure if the ghost was conscious, and if there was like a 20% chance that the ghost was conscious, that the ghost wasn't conscious, and then maybe instead of this being a 2, it's to a 0. Just pretend that's a 0. So, or actually, no, just add a shape, just add a sphere. And then increase the thickness. So, and say maybe we weren't sure if the AI was conscious, so if the ghost was conscious, maybe we'd update this, and maybe we'd update this whole thing using basically the same method. So that's how that's how our AI might learn over time what ghosts are conscious, which people are conscious, which animals are conscious, how different people react to different things. A sad person might be more likely to cry than a happy person, and that's how an AI might learn that probability. And it might... So that's how an AI would learn what people are conscious and whatever. All that other stuff on how an AI might continually learn about this stuff. If we want our AI to be perfectly moral, then, this isn't AI specific. This just is how the world works, that there are some probabilities of different things being conscious, some correlation between physical state and how different conscious states will be, and how different conscious states, being happy if Pac-Man is all the way over there, or being sad if Pac-Man is all the way over there. Just draw back the negative sign. And then there's some free will that determines the probability that a happy person or a sad person would do a certain thing. That just is how the world works. And if we want our AI to be perfectly moral and use the best information to make the best decisions it can, given its information, it's going to have this as a model in its brain somewhere in the code. It's going to have this. And you're going to have to choose the right priors. More specifically, I write down what the set of priors might be here. So if you're actually implement this is the name of the article. It's by me. This is possible priors. The set of possible priors. And in the next video, we're going to talk about how bad it would be if the AI had the wrong priors using a lot of math. As a preview, it's going to look a little like this. There are going to be some circles. Before that, just want to insert a brief note on this topic. Alan hijack.
I think in theory, if you get a lot of empirical information over time, then the influence of your starting point becomes more and more gradually irrelevant over time as it's kind of washed out by all these updates you're making, conditionalizing on things that you've observed. So that's one thing, at least if you're around long enough and collecting enough evidence to move away from the very first prior that you started with. I guess another difference I can imagine is that I think in theory you're meant to start with something like an uninformed prior, or which is to say a prior that is extremely agnostic. It isn't really pretending to know all that much. Now, I think it's a bit hard to define exactly what is the appropriate uninformed prior, but the hope is that your views are going to be very flexible initially, because it would be presumptuous, it would be foolish to think that before you've looked at any evidence you should have a really strong view about things. So maybe that's one way in which the prior case is, well, the prior should hopefully be doing not that much work, even if we do concede that it is largely arbitrary.
Excellent. Both good replies. The first one was the washing out of the priors in the long run, and there are these famous convergence theorems for Bayesianism that in the limit, under certain appropriate conditions, effectively the prior is completely washed out. And that's good, but then, as Keynes said, in the long run we'll all be dead. And at any point in our finite lives, we will not have reached that limit. And the worry is that the residue of the prior will remain at all of these finite stages, which is all we ever have. Okay, so it's nice to know that there are these theorems that we'll get there in the end, but the problem is we're never at the end. And regarding the second reply, and that's certainly a good one. Yes, I think actually that's the way to go, that you want some sort of constraints beyond the probability calculus on the priors. And as you said, maybe uninformative priors. As we might say, maybe there are some constraints on what the prior should be, not just anything goes. And in fact, there's the so-called uniqueness thesis that says, no, there's even exactly one. There's only one rational starting point.
And some things that I just forgot to note real quick. One, we only need to be precise enough with our priors such that it's no longer worth it. Try to be a bit more precise. We don't need to spend millions of dollars to figure out whether a dog wagging its tail means a dog is 2.500000001 times as happy as normal, or 2.5000002 times as happy as normal. That just isn't worth the money, so that's how we determine when to stop getting to be more precise with our priors and when to start actually running the AI. That's the first point. 2, we can add any priors we want to the AI, so long as they eventually don't affect the AIs too much. That convergence theorem that was just mentioned, ignore this. This basically just means that it depends on what universe we live in, whether this is true or not. Maybe it isn't true for some universes. Maybe it is true for some universes. But anyways, example, we can code into the AI's moral weights, how much it values each possible moment that the world could be in. Quote, world states with a dog in them have a 99% chance of having plus 1 million coins or rewards or whatever else in them. It's really good if dogs exist, so probably don't kill all the dogs. And eventually, once the AI doesn't need that safety guardrail in place, it'll learn that, hey, wait, worlds without dogs are okay-ish. I mean, they're bad, they're much worse than worlds with dogs, but eventually it'll learn that. But as a starting point, it's useful to have that be said. 3, we can use another AI, which is just a chatbot, to detect when a decision is very bad. Chatbot can shut off from hitting AI, or at least override a certain decision. So maybe, if main AI assesses that, hey, I think it would probably be really moral for me to kick that dog over there. I would learn more about if dogs are happy or sad when I kick them, something. Then might have this chatbot AI just look at that as a request and say, hey, no, I know you think it's a good idea, but we'll just stay on the safe side and say, no, don't do that. Or the AI was like, hey, I'm thinking I'm going to take over the world because the current world has dogs being kicked, and I want to stop that. Maybe the current AI would be like, the chatbot AI would be like, hey, maybe at least do a worldwide referendum or something before you go on and take over the world. Don't take over the world. So it would be nice to have that as a backup. 4, for our prediction bot, the bot that gathers information about the world and how different things will lead to different consequences, is feel free to read that. If you don't want to read that, don't. If you do want to read it, do. It's just a prediction bot, the AI that about this red stuff, the information. So again, to recap, feel free to take a picture of this on your phone and save it as a reminder. And again, if you're not sure what I'm talking about, watch this. That's it.